Motion. Talking about motion, this is the movement of a body from one point to another with respect to a particular observer in a given time interval. When you talk about motion, there must be a movement from one point to another. Example, from point A to another point B, and it must be a particular observer that is taken there. Because if I have an observer on A and I ask the observer, where is this motion heading to? The observer will tell me it's moving out of him, while the person on B will tell me that it's coming to me. So motion is always referenced to a particular observer on a inertial frame of reference. And we have four basic types of motion. The first one we call random motion. The second one we call translational motion. And the third one we have rotational motion. While the last one is what we call oscillatory motion. The first one, which we call random motion, is a kind of motion that has no specified direction. Example, if you fill a balloon and throw it into thin wind, you cannot specify the direction in the next 3 seconds. While translational motion has its own basic character. For you to say that something is translating, that thing must be, one, rigid. It's something you can hold. You cannot talk about translation of water. You cannot talk about translation of air. It's something that is rigid, something that is solid, something you can hold. And that must move without rotation. Example, the movement of a human being. Rotational motion. This one is a kind of motion that revolves around a concentric circle. When I say a concentric circle, I mean a circular body in another circular body. Example, fan blade. It rotates about a particular fixed point. Then we come down to oscillatory motion. The basic character of oscillatory motion is repetition. The motion must repeat itself about a fixed point. Example, our simple pendulum. When you let it to one part and allow it to oscillate, it goes to and fro like that and keep repeating itself. We'll say that such movements, which consists of to and fro movement of a body repeating itself, is called oscillatory motion. Parameters of studying motion. The first is position, because you can't say where something is going unless you know where it is at the moment. Talking about position, we are talking about locating a point in space with the Cartesian coordinates. Cartesian coordinates simply means your xy coordinates, where the horizontal is the x coordinate, while the vertical is the y coordinate. Whether it's in the positive part of x, negative part of x, negative part of y, or positive part of y. Once you can locate that in space with this Cartesian coordinate, we'll say that that is the position of that particular thing. Secondly, we talk about distance or displacement. Both look alike, but they are not the same. Distance is the length difference of two positions covered through the path of the motion. Example, if I have someone that moved from A and head on to B, and maybe the person moved through this path to that particular position, we'll say that this is position A and that is position B. Moving from A to B through this path, we call this particular path, the length difference from this A to B through this path, the distance. While the straight connection from A to B is called displacement. So we'll say that displacement is distance traveled in a specified direction, while distance is just the length difference through the path of the motion. Distance has no direction. Displacement has a direction. So distance is a scalar quantity, while displacement is a vector quantity. We come down to the third one, which is speed stroke velocity. Speed is the rate of covering distance with respect to time. Then Mr. A moved from A to B. At what time? 5 seconds, 5 minutes, 5 hours. The distance covered divided by the time given is what we call our speed. While velocity is speed in a specified direction. Someone else may define velocity as the rate of covering displacement with respect to time. So mathematically, we'll say that this boat, V, is equal to x all over t, where x is distance and t is time. Then the fourth one, we talk about acceleration. Acceleration, which is the rate of change of velocity with respect to time. At the rate by which the velocity of a body is changing with respect to a given time is called acceleration. When it's increasing, we'll say that it is accelerating, while when it's decreasing, we'll say that it's decelerating or retardation. So after acceleration, we talk about retardation, which is the rate of decreasing velocity. Mathematically, we'll say that acceleration is change in velocity all over time. Some will tell us that acceleration is velocity over time. No, it is change in velocity, not velocity itself. And in some textbooks that you see, A equal to V over T, it's not that it's velocity over time, rather the initial velocity there is equal to 0. Since it's 0, V minus 0 is also V. That's why we have V over T. But the real definition of acceleration is change in velocity all over time. Talking about Newtonian motion. This is the part of physics converted into mathematics by a man called Newton. He used experiments in physics to get 4 basic equations that handle every problem in motion. The first one, which we call the first equation of Newton, states that V is equal to U plus or minus AT. The plus there represents when the body is accelerating, while the minus there represents when the body is retarding. The second equation says that X is equal to UT plus or minus half AT squared, while the third one, V squared, is equal to U squared plus or minus 2AX. Then the final one, which is the fourth one, which we got from the definition of distance, X, which is the product of average velocity V plus U over 2 times time. Now explaining the parameters here, V here simply means the final velocity of the body, U the initial velocity of the body, while A is acceleration when it's positive, or deceleration or retardation when it's negative. S is the distance. This is the definition of distance. U plus V over 2 all together represents average velocity. Now, but if it's in vertical component, this can represent the horizontal because X is horizontal distance and acceleration is horizontal acceleration. But if it's in vertical, we can rewrite these things as V equal to U plus or minus GT, where G is acceleration due to gravity or acceleration of free fall, while the second one will be H. Instead of X now we have height. Height equal to UT plus or minus half GT squared. This one we have V squared equal to U squared plus or minus 2GH. While the last one remains the same, S equal to, the last one becomes H equal to U plus V over 2, all multiplying what? T. And these are equations of Newton, which can take care of any problem on linear motion. Graphical study of motion. There are 2 basic graphs that takes care of the mathematical study of motion. The first is what we call distance time graph. My dear, in this one, the basic thing they want you to know is that the slope of a distance time graph, this is our distance on the vertical and this is the time. And if I have this to be my graph, that the slope of a distance time graph is simply giving us the speed of the body. Because if here is delta x, which is change in distance, and here is delta t, which is change in time, delta x over delta t is equal to speed. If we now make it displacement time graph, that means that the v here will simply be velocity. The second graph is velocity time graph. Velocity time graph. Many a times in examinations, they try us a lot on this part. The first thing they would like us to determine is acceleration from velocity time graph. And when you are asked to calculate acceleration from a velocity time graph, it simply means the slope of that particular graph. For example, if I have this to be a velocity time graph, v and t, and this is the graph, asking me to calculate the acceleration, make up your slope triangle. Here is delta v and this is delta t. Taking up the slope, we say that slope is equal to delta v over delta t, which is still v over t, change in velocity all over time, which is the same thing as acceleration. But when the graph is a negative graph, something this way, coming up like this, here is v and this is t. This time around, we will not have acceleration but retardation. Because it's decreasing, it will give us a negative graph. Having this, we have delta v and delta t. It will give us a negative graph because slope of the negative graph will give us delta v over delta t. And since from here, the initial velocity is greater than the final velocity, we have minus v over t, which is negative change in velocity over time, which in all will give us retardation. Okay, knowing fully well how to get your acceleration, the next thing we'll have to know is how to calculate the distance traveled using our graph. Whenever you are asked to calculate the distance traveled using a graph, what I want you to calculate is the area enclosed by that graph. Example, if I have a graph this way for you and say calculate the distance traveled by the graph, I just want you to calculate the area enclosed by this triangle with your normal formula for triangle, which is half base times height. But in this area, get this, that whenever you are asked to calculate or draw a particular motion with respect to this graph, velocity time graph, you are expected to know when it's going up, when it's not moving at all, and when it's going down. When they say that the body is moving with a uniform acceleration, that means that the body is accelerating, is increasing in velocity, so it will go up. Then they may tell you that the body maintains the velocity or it moves with uniform velocity. At that point, it's neither going up nor going down. We have it going straight that way because time is still increasing while velocity is not increasing. And they may also tell you that it's decelerating and finally comes to rest. That means it will come down and come to somewhere here. This is a particular diagram of a motion. So I can ask you to calculate the total distance traveled here. There are so many ways you can do that. You can divide this into 3, label them I, and I. What will you do? You go ahead and find the area of I, and I, then sum them together, which is triangle, that is half base times height. Here is a rectangle, length times width, plus another triangle, that is half base times height. Or you can go ahead and calculate this in general as area of a trapezium. And once you are able to do this, to know that whenever you are asked to calculate the distance, is the area enclosed, and knowing how to get your acceleration from graphical representation, and taking care of Newtonian motion with all those equations, I think these are the basic things we need to know as long as motion is concerned. And that will bring us into another relevant topic which we'll look at now, called friction.